In this video, we're going to find the LU factorization of the matrix A. Our goal is to write A as a product. First factor will be called L, second factor will be called U, and L represents what's called a unit lower triangular matrix. So what that means is it's got 1 on the main diagonal, and it can have any real number entries below that diagonal, but it's got to have zeros above the diagonal. So it's called the lower triangular matrix because all the non-zero entries are sitting on or below the diagonal. U is an upper triangular matrix, so it can have any entries on or above the diagonal, so any real number entries, but should have zeros in these positions here. So let's just say star represents any real number, and there we have our description of the LU factorization. The way we're going to find the factorization is by starting with the matrix A, and we're gradually going to turn it into the matrix U by doing only one type of row operation. So the only type of operation that we're allowed to do is replace a row, let's say row I, by row I minus k times row j. So if we rephrase this, we're basically saying we're not allowed to swap rows, we're not allowed to multiply or divide rows through, we're only allowed to do this particular type of elementary row operation. So I'm going to recopy our matrix A, and we can get started. What we'd like to do is get zeros in these two positions here. So we can first take row 2, and we can subtract off 5 halves of our pivot row, which will be row 1. So we can check that if we go 5 minus 5 halves times 2, that's going to give us a 0 in this position. So this is how we chose that multiple, that minus 5 halves there. To get a 0 in the bottom left here, we'll have to do row 3 minus 2 times row 1. Now, before we figure out all the entries in this matrix, I want to point out that this multiple here that we're using is going to be important when we write down our LU factorization. So beside the matrix, I like to record what the actual k value is. And remember that the way that we defined our operation over here, we said we're replacing row I by row I minus k row j. So meaning if we've got a negative multiple here, k is going to be positive. K is actually positive 5 halves here. K is positive 2 here. So you can think of k as the multiple of the row that's being subtracted off. In other words, there's a sign change going on. All right, so let's figure out the entries in our matrix. The top row stays the same. 2, 2, 3. If we do row 2 minus 5 halves row 1, we're going to have 0, 4, and if we want to do a little calculation over on the side here, we'll have 10 minus 5 halves times 3. In other words, 20 halves minus 15 halves. In other words, 5 halves. All right, so that's what's going in this position here. I'm just going to keep this calculation out of the way. In the bottom row, we'll have 0, negative 3, and negative 4. So that is our first step all done, and we've remembered to record our k values, again watching for that sign change. So next step, we're going to try to get a 0 in this position here. To eliminate this negative 3, we're going to have to go row 3 plus 3/4 row 2. So we can just do a double check that, yeah, if we did negative 3 plus 3/4 times 4, that's going to give us a 0 in that position. So that is the right multiple to use. And if we want to record our k value here, remember k is the multiple that we're subtracting off. In other words, there's a sign change going on here. K is -3/4. All right, so we'll use this value a little bit later on. Let's fill in our entries. The top two rows are not changing. And in the bottom row, we've got 0, 0, and then we may need to do a little calculation here over on the side. We've got -4 plus 3/4 times 5/2. So if we put everything over 8, we've got -32/8 plus 15/8 gives us -17/8. And that's what's going to go in the bottom right-hand corner there. So at this point, we have found an upper triangular matrix. This is the matrix U that we're going to be using in the LU factorization. And to get the matrix L, we just need to know how to build L. What L does is it records the k values in the appropriate positions. So let's take a look at this matrix L. It's going to have ones along the main diagonal, zeros above the diagonal, and then we need to look back at our previous work here. So when we got a 0 in this position here, the k value that we used to achieve that was 5/2. So that 5/2 is going to go into that appropriate position, the position where we were creating the 0. To create a 0 in this position, we used a k value of 2, so that goes in the bottom left, and we used a k value of -3/4 to create a 0 in this position here. So at this point, I'm just going to erase our rough work that we did over on the side, and that will give us room to write up our final answer. So our matrix A that we started with equals LU, where L looks like this. Let's go. Ones along the main diagonal, and it records the k values that we used when we got our matrix into upper triangular form. And the matrix U is just that upper triangular form that we found when we were done doing our row operations. So we'll put a box around that, and that's our final answer.